Okay, this is a physics lesson on section 21.2, and the title of that section is Energy and Electric Potential. What I am going to try to do in this lesson is help you understand one of the most misunderstood concepts in physics, especially in electricity, and that is the concept of voltage. Voltage is misunderstood. If I say that something has a million volts, people are panicked. And yet the globe that we used, the Van de Graaff generator where it would shock me, that's producing easily 250,000 volts. I would be much more afraid of 250,000 volts. Of 120 volts or 240 volts that you have at home than the 2.5 million or 250,000 volts that we have here. Why is that? Well, that's because voltage does not actually measure what people think it measures. It measures the amount of work that we can do on a charge. In fact, the symbol for the equation for voltage is delta V is equal to W, this is out of your book, on Q1 divided by Q1. If you look at that, voltage is work divided by charge. It's the amount of work that will be done on a charge. Notice what it says here. It doesn't say V, it says delta V. And that's because when you start doing work on a charge, if you move a charged particle in an electric field, you're going to do work on it. It's always a difference between where you started and where you ended up. My father was an electrician, and he used to always refer to voltage as potential difference. He wouldn't say voltage. He would say there was a potential difference of 12 volts. He would say volts, but he would always say potential difference. There's a difference in the potential energy of that particular object. Now, in order to understand that, we really have to back up and talk about gravity. So think about having here's the Earth, and I lift an object up. And we learned way back when that work is always force times distance. And force, in this case, is mass times gravity times height. So if I was to say, this is review, I have 1 kilogram, and I'm going to lift it, say 1 meter. The work would be 1 kilogram times 9.8, by the way, newtons per kilogram, times 1 meter. And that would end up being, lifting this 1 meter, I would have needed 9.8 joules. Okay, so you may remember that from before. So let's do this. Let's say that we had an object here and we lifted it up 1 meter. And I asked, how much work did we do on that? And the answer would be, how would I know? I don't know what the weight of the object is, but what I could do is say this. If I took this equation right here and went work divided by mass is equal to GH, notice that this depends just on gravity and height. So the units here would be joules per kilogram. And at 1 meter, we are at 9.8 joules per kilogram. Let's say that we moved up 2 meters. We would then be at 2 meters times that, 19.6 joules per kilogram. Let me go up 3 meters. I'll take that off of there. 3 meters. We would be at 29.4 joules per kilogram. That is called the potential difference. This is actually equivalent to what voltage would be. So if I was to take, let's see if we can see this or not. If I was to take and put an object here now, and I was to say, how much work is this going to do when it falls? All you need to do is tell me how many kilograms it is. So if I said, oh, and this is a 15 kilogram object, Well, then the amount of work that was done is 9.8 joules per kilogram times 15 kilograms. So that's 980, and 49 would be, I should have done one that was easier to do than that, but basically you could multiply that out. Hold on, let me get my calculator. 98 times 15, this would be 1,470 joules. Okay, but this is the key. If I moved this twice as far, well then instead of 1,470, it would be 2,940, 2,940 joules. If I moved it all the way up to here, but the point is because it's 15 kilograms. But what if it wasn't 15 kilograms? What if this was 0.5 kilograms? Well, then I'm still at the same difference, 9.8 joules per kilogram, but because it's only 0.5 kilograms, an object that only weighs 0.5 kilograms would only have gained 4.9 joules of work. All right? So here's how you think about voltage. Voltage is the work that can be done that will be done on a charge in an electric field. The units for voltage are actually joules per coulomb. By the way, sadly, we have no unit for this. But if I was going to call it something, I would call it